So, good morning, everybody again. So, I'm going to present these topics about the tsunami basic idea and to introduce you the future of the tsunami disasters in 2011. So, 1 hour is enough, I think, to help your understanding. But maybe you have many questions and some comment. So we are free, have the free time for two days, including the some visit. So anyway, this is my contents in my talk about some history of the earthquake tsunami before 2011 and also countermeasures to mitigate the earthquake tsunami in this area. But we are not enough to prevent the huge disasters. And the second one is the introduce some seismic activities of the huge earthquake and also some future of tsunami which are observed offshore and onshore. And third is the topics for the reconstruction or some discussion for the future in the affected area and also Japan. So let me start the introduce the past activities of the earthquake and tsunami in Tohoku area. So we have many records over the 400 years or so on. However, we could not evaluate or predict the huge earthquake magnitude 9. So why? So I'm going to present. So anyway, this is a map to showing the area of Tohoku. So where we have many earthquakes because the oceanic plate is going to subducting underneath of the Japan. And we have the another plate, ocean plate and continental plate. So the many stress can be accumulated. So regularly we have the earthquake followed by the tsunami. So when we look for some historical document to know where and what type of earthquake and tsunami happened. So we can make a review on the historical document and records. So you can see the sum table here. So this is 869 or 6011 and so on. So you can see we have I think enough scientific data about the earthquake during 400 years. Since samurai started some constructed communities and many some report or diary become common for the human people. So we have lots of historical information and data in Tohoku area as well as other area in Japan. But before 600, we have less information about earthquake or other disasters due to the limitation of the description in the record. So anyway, we are using this kind of historical data to see the some repeatedness or frequency of the earthquake. So when we have some information or some record on the earthquake and tsunami and which damages, we can estimate where earthquake tsunami happened. So, for example, we have many damages along the coast due to the earthquake tsunami from here to until here. So roughly we can estimate the source. And some differences between the damage level between the coastal area or inside, we can estimate the distance. So we have big differences here, maybe some close the source, but the difference is small. Some source should be far from the coast. So by utilizing such kind of information distributed many places, then we can estimate the source area. So once we can get this kind of information, we can understand the activities. Then we can find some regional characteristic of the occurrence of the earthquake. For example, here, green area, we have 1, 2, 3, 4, 5 events of the earthquake during the 400 years. So average repeatedness or some average duration time might be 80 years per event. So with magnitude 8.5 to 7.5 to 7 to 8. So we have some future or regional future of the earthquake here. However, if we are looking to the next area here, we have only 2 earthquakes for 400 years. So we have less earthquake, and it means the stress can be accumulated for a long time. So big earthquake happened, more than 8.2. So we can understand the sound characteristic in the region for the earthquake. So please look at the area offshore the Miyagi. It is very high activities. So more than 11 events for 400 years. So it means there's some interval of the earthquake is almost 37 or 40 years. So this is one of most active or most regular repeated earthquake in the world. So last event in Miyagi, 1978, we had no earthquake and tsunami for 2 years or 30 years. So we were thinking about some earthquake and tsunami should be happened very quickly. Then we are looking to the another area here, for example, 1793 or 1897, the two events, another earthquake followed at a very short time. So this is a unique earthquake, but sometimes multiple earthquakes happened. So we have 2 examples. So here we have the 7.5. It is the average magnitude of the earthquake in Miyagi, but sometimes we have the magnitude 7.8 or 7.8 or 8. So it is multiple. So this is our information, our knowledge. So in added, we have some observation system to see the current seismic activities. For example, here, we are centered here, Tokyo, and north part of the main island, Shimokita. So this is the seismic activity for 30 years before 2011. So you can see many earthquakes here, everywhere in the ocean, and less activity of the earthquake on the land. And there is some seismic gap. Should be very active, but at that time, before the 2011, we have small number of the earthquake. So we can notice there. So this is a very good example for the people to understand so where we are living with some earthquake. So this is very good information to see the distribution of the earthquake. But this is actually information of the epicenter of the earthquake. So now you can see the 2-dimensional image from the top, but we can change the direction like this. So here, very easily understand for us to know where earthquake happened at the boundary of the 2 plates. Oceanic plate and also the Asian or North American plate. So this is the boundary. So in the shallow region, earthquake with yellow dot, very high active. And going to the down or in the deep, we have very some earthquake again. So by using this kind of information, we try to evaluate the activity of the earthquake. So this is the one of result through this kind of seismic research. So this is the one of result showing the tsunami distribution along the coast from north to south by the central government, so which is the cabinet office under the prime ministers. So which compiled all kind of data for earthquake tsunami, and they can estimate some potential of the earthquake tsunami, and some of results showing on the map, including the hazard map. So here, this is the top north of the main island, and this is the Sanrik coast. It is rear coast type, very complicated coastal line, and we are here Sendai, and it is the bay, and Fukushima, Ibaraki. So for that area, we can estimate the some potential tsunami. So red one is the Meiji Sanriku, around 100 years ago, 1896. It happened, and you can see the very scattering data. So it means the tsunami can be very changed in each area. So especially the bottom of bay, we have very high height of tsunami due to some energy concentration. So energy, anyway, it is a very big change along the coast. And this is Iwate. We have very high tsunami, 10 to 20, or sometimes reach to the 30. However, when we are going to the Miyagi or Fukushima, historical tsunami is very small compared with the those in Iwate, because the earthquake and tsunami happened just offshore the Sanriku. So tsunami propagates to the other area, Miyagi and Fukushima, but this peninsula, Ojika Peninsula, can make some rule to prevent tsunami, like seawall or breakwater, and protect this area in the past. So that's why we have the tsunami less than 5 meters, or even though some area reach to the 10, but it's very small compared with the tsunami in Iwate. So this is a previous research work. So based upon the result, we make the hazard map, including the inundation area. However, 2011, the huge earthquake happened, not only Sanriku, but reached to the Fukushima and Ibaraki. So quite different type of the earthquake, which generated the tsunami, huge tsunami. So black dot is the measured tsunami in 2011. So this area maybe a little bit large than Meiji, but not big differences. However, in Miyagi and Fukushima and Ibaraki, you can see the big discrepancy like this. So this is the inundation area. Before the 2011, we estimated the tsunami inundation area like this. Here around here we are Sendai. This is Sendai Station, and this is the Sendai Bay. So along the coast, we have some effect of the tsunami, but not so large. However, 2011 tsunami affected to the Sendai Plain area, so the total area become large. And this is the Sendai city in the plain area, and Sanriku also. So I mentioned the height of tsunami is not so big differences between them. However, inundation area might be very large compared with the past. So blue one is the past tsunami we estimated, but this time 2011 exceed this area very big. So once again, I would like to show you the activity in the past for 400 years. So this north and central and south, we have very small earthquake offshore the Fukushima and Ibaraki. So main concern in Tohoku area is like this. However, we have the large earthquake, magnitude 9, from north to the south. So there is big gap or big differences. So that's why big tsunami affected the Sendai area and also Fukushima. The nuclear plant is located here. So this is the same activities. So which is we know. However, the 2011 is the unpredictable event. So we are now thinking about some process or seismic cycles of the 600 or 1,000 years. So this is the some time, year or time, or this is some accumulated the stress, or we can say the slip to release some energies. So when we are studying the historical earthquake, we know the some frequency. In Miyagi, for example, every 40 years, we accumulate the stress and release, and accumulate and release. So we know the normal cycle. However, 2011 Tohoku, we have very large slip or dislocation, maybe 10 times or 20 times larger than this. So actually, this figure suggests maybe we have another stress which cannot be released by the normal earthquake, magnitude 7.5, and so on. We have still accumulated for 600 years or 1,000 years. Then that stress can be released in this time. So when we have such idea, we can go back to the previous event. For example, to 1611 Keicho or 896 Jogan might be same or similar magnitude of earthquake with the 2011. So this kind of event we can call the super cycle in this area. So this is some result, or still our estimation or assumption so far. So anyway, due to the limitation of the historical earthquake tsunami for 400 years, so we should overcome. So then we are looking back to the historical document more carefully to read some description for understanding what happened. So this is the documentation around 1,000 years ago, 869. So we have the Sandai Jitsuroku old document in Kyoto. But to describe all major events in Japan. So this is the description about the Tagajo nearby the Sendai, about the earthquake and tsunami and some earthquake lightning and so on. So we in the past tried to understanding the very roughly. So just earthquake happened, big ground shake, and some cracks, and lightning happened, then a tsunami might come. But we need read carefully about each word. For example, this is the name of the place, Mutsu. So this name of place sometimes change. So at the present now, Mutsu means the part of the Shimokita in the top of the main island in the north. However, several hundred years ago, it's not in that area, but covered Miyagi or Iwate. And 1,000 years ago, the name of Mutsu covered very wide area, for example, Tohoku. So depend on the time or depend on the age, the name of the area not meaning with the very different areas. So we need the help from the historian to understand where. So this is the example. So now we are again reading some documentation very carefully. However, still we have the limitation of the information on the document. Then we are now trying to find some tsunami evidence. For example, sediment or some layer under the ground. So this is the example of the some layer in Sendai. So this is the mat, and this is the normal layer, but we have different type of layer. For example, which is the layer of the ash. So 915, we have the volcano eruptions in the Towada, north part of the main island, so which affect to the Miyagi or other area. So very clear layer due to the volcanic eruption. So we know, we have some database to know which volcano erupt and when. So then, by taking some material and analyze it, so we can identify the eruptions. So this is 900. So which means some area about the layer might be new, and under this area should be old. So then you can see another sand layer which coming from the coastal area, because the different size and some small shell contains in this area. So this is not original from the land, but from the ocean. So we are now expanding this kind of research on the field. So this is a coastal area, and you can see the small black dot. So this is the place where we take a sample to know some tsunami sand layers. So we have the many samples, more than 250 points. Then we found that the tsunami sand layer we found until this area. So from shore to this line, everywhere we found this sand layer due to the tsunami. But this area outside of this boundary, no layer. So it's suggesting the tsunami inundation area. So this kind of research work should be carried out in the other area, not only Sendai, but others. So anyway, let me change the second topics about the Tohoku earthquake and tsunami in 2011. So again, please look at the area of the main shocks. So actually, this is the epicenters. So which is almost same as the Miyagi earthquake in the past, 37 years cycle. So the place of the earthquake epicenter is almost correct, which we are thinking. And 2011, it happened very quick, very soon. However, the earthquake of the magnitude of earthquake quite different. 7.5 earthquake like this, but this time 9 like this. So this is another aftershock immediately in the north and south and east. And the black dot showing the aftershock distribution. Still, we have the many aftershock almost every day. So maybe during your visit, you might feel some shake. So anyway, this is the seismic activities in 2011. So by using the data observed for the earthquake tsunami, we try to estimate distribution of the slip on the fault. So this is the epicenter again. So we have very large distribution offshore, reach to the 30 meter in the event. But north and south, so less distribution. However, this area is so large, we have never had such large earthquake in Japan past. So once we can estimate the distribution, we can calculate the vertical displacement of the sea bottom like this. So this is the up and the blue one is down. So subsided and uplifted. So this is the distribution, or we can say the initial condition to generate the tsunami. So this is Sanriku. In the past, we have some earthquake tsunami like this, but it's in 2011, it's expanding to the south like this. So here, you can see another observation data about the tsunami by using the GPS monitoring buoy. So here, Iwate, north and middle and south. We have 3 stations in Iwate and 2 stations in Miyagi, and this is Fukushima. So you can see the time, March 11, 1446. This is the time when earthquake happened. So in the beginning, some data cannot transfer to the station, but it's recovered. So you can see the first or initial motion of the tsunami. So tsunami going down. So it is initial, and next the positive wave followed like this. So you can see a kind of secondary tsunami component. So we can evaluate the tsunami waveform like this by using this initial condition. So this is a negative wave and a positive wave. So it's very large scale of the wave. So maybe it's negative wave and a positive wave. So this is the typical tsunami behavior we can estimate at the current. However, the secondary component of tsunami wave can be added. So due to the very special mechanism of offshore during the earthquake happened. So you can see the secondary tsunami component. But these are very significant in the Iwate, but in Miyagi, it is not so significant, but not positive wave, but the receding wave become large. So we have some time differences or some another mechanism of the earthquake. So this is the record of the tsunami to detect the first motion of the tsunami. So here you can see the observed tsunami offshore the Fukushima. So there's some ships, marine safety ships are just offshore the Fukushima, 5 kilometers from the coast. So there are some guard for Fukushima nuclear plant. Oops. So actually, this is the sea surfaces. So due to our analysis, the first wave of tsunami already arrived. So normally tsunami is very, very long wave. So even we are on the sea, we cannot see the change of the sea surfaces down and up. So this is the normal condition of first wave. However, secondary tsunami is coming. So this is abnormally short and very large, which is very destructive. So here you can see the secondary wave of tsunami offshore that Fukushima. second wave coming. Yeah, so this is an observation of the tsunami, especially for the secondary wave. So it is significant in the Iwate, but not so in Miyagi, but again significant in Fukushima. Okay, so as you know, the Japan Meteorological Agency have the tsunami warning system. So it started 50 years ago. So one of very good system, we believe. So whenever earthquake happened, we can provide about tsunami. So it is occurred or not. So at that time, 2011, March 11, we have the earthquake and it's monitored. And within 2 minutes, we can get the information of the magnitude and also tsunami information. And it is the quantitative information when and how large tsunami attack. So it is epicenter in Miyagi, it is correct. So, but at that time, estimated the magnitude was 7.9. It's much less than actually magnitude 9.0. So at that time, only 6 meter in Miyagi, 3 meter Iwate and Fukushima. This is the first information of the tsunami height. So which are very underestimate for the actual tsunami. So this is the record of the JMA tsunami warning. So 2:46, just 3 minutes after the earthquake happened. So JMA estimated 7.9. Actually, this is 9.0. Due to the some limitation of the JMA warning, which depend on the magnitude. Once we can get correct magnitude, we can provide correct tsunami height or arrival time. So we fail to estimate the tsunami earthquake magnitude due to the some scale out of the seismic monitoring. So we have never have the large earthquake more than 8.5. So we put some upper limitation about 8.5. So but this time 9.0, very strong shake and long time. Then we lost the data to estimate the magnitude, or some data scale out. So this is the reason. However, around 20 or 30 minutes, we have GPS data like this. Oops, sorry. We have GPS data. This is the real time. So JMA staff member observed the change of the wave elevation. So in the Iwate, it's exceeded 6 meters offshore. So the staff are very much surprised at so large tsunami, even offshore, observed. So by using this kind of real-time data, they change the tsunami information like this. In Miyagi, from 6 meters to 10 meters, and Iwate and Fukushima. And other area, Aomori and Ibaragi, it's expanded. And again, it's expanded like this. So this kind of information in GPSV or sea bottom wave pressure gauge were available at the time, which can correct the first estimation due to by the JMA about the earthquake. So this is the comparison of the actual tsunami data recorded by the tidal station or GPSV. This is black. This is some dot is some estimation, and blue one is the JMA tsunami information. So as I mentioned, for example, this is Ayukawa in Miyagi, first tsunami height 6 meters. And secondary, it changed more than 10 meters. And this is the Ofunato in Iwate, first information 3 meters, and changed to the 6 meters and reached to the 10 meters by using the real-time offshore record like this. So when we are comparing the actual data and JMA information, it might be not so bad. Okay, so this is a tsunami, and when tsunami become large, the information can be changed. So scientifically, we have, I think, enough accurate information for the people. But the people on the site could not receive the secondary or revised information due to the stop services for the mobile phone or electricity stop completely. No way for the people to get further information. So it is very, very critical. So JMA or other people outside of Tohoku knows about the change of the information like this, but people in Tohoku could not get this kind of information. So this is our critical issue to provide tsunami information. So anyway, we are carrying out the tsunami field survey from Hokkaido to Tohoku and Miyagi and Fukushima to the Tokyo and other area. So here you can see the maximum tsunami run-up height reached to the 40 meters in the Sanriku area, and you can see the very big differences, so scattering due to the topography of the rear coast in Sanriku. And here, this is Miyagi, more than 10 meters or reached to the 20 meters. And you can see the red circle, so which is area for Fukushima nuclear plant. So in the last year, we are not allowed to go inside of this area because of the high radiation. So this year, in the beginning, we can go to the side and we measure the tsunami height like this, and the maximum tsunami run-up height reached to the 21 meters. So it is very large tsunami attack to the this area. So this is the situation. So by using this kind of information, we can estimate the tsunami source like this. So this is epicenter and large dislocation to the uplift and subsided. So this is the first model by Tohoku University. This model cannot include the secondary tsunami component. You can see it very large and short. But anyway, this is the first distribution. So by using this initial information, we can reproduce the tsunami. Oops. Okay, now tsunami generated. So this is the time. Now 10 minutes passed. So it's first negative wave first, and next positive wave followed. So this is the Sanriku. Then when tsunami attack, the behavior of tsunami is big change due to the refraction or concentration in the bay of the Sanriku. And 40 times the tsunami reached to Fukushima here. But this is Sendai Bay. It is very shallow. So tsunami are late to arrive to this area. So it is very simple compared with other area. So once tsunami go up, so it means inundated or run up, then due to the gravitation, tsunami going back to the shore ocean side. So you can see the reflected wave like this or like this, which can propagate to the other area, to the coast, and some area going to the Hawaii or Chile, propagating across the Pacific Ocean. So really it is big tsunami affected to the very large area. Now 2 hours passed, but the tsunami oscillation continued for a long time. So here, this is the behavior of tsunami offshore. So when tsunami coming, so this is a secondary tsunami simulation from the source to the coast, then tsunami inundated. So you know this is Sendai International Airport, located to the coast, maybe 500 meter to 1 kilometer. It's very close. So here we try to again to simulate the tsunami. So color is the positive and negative, and you can see the velocity. So it means current velocity here. So once tsunami inundated, but it's continue to propagate in the plain area. So this is the airport with the some stations. So around 1,000 people are here to save their life. So it's okay. So it's propagate to the inside, and this is 1 hour and 90 minutes past. So here we have the highway with 8 meters above the ground level. So this is not purpose for the tsunami mitigation at the time. But here this time, like a bank of the highway can stop the tsunami. Without this bank, maybe tsunami going to the further more inside. But this time we can stop this way. So anyway, now 1.5 hours passed, and the second wave coming, and this is inundation due to the only first wave. So we can understand. Now tsunami reached to the highway and can stop very quickly. Okay, so at the result, so we have the sea walls or breakwater along the coast, because we have many historical attacks of tsunami in the past. So we try to prevent the tsunami by constructing the seawall, 10 to 15 meters. But this is the Sanrik area. However, the Miyagi and Fukushima, the height of the seawall become very low because the past tsunami was small. And yellow dot showing the tsunami of 2011. So you can see some differences of the level of the seawall and the tsunami. So as a result, we have big inundation like this. So many houses, infrastructure are damaged. However, some shelter, so it is the some evacuation place for the people to save from the tsunami. It might be okay. So in Kesenuma, many people go up to the second floor or the third floor or top. Then the tsunami come, but you know, this building are isolated for 2 or 3 days. So they should stay more than 3 days. So it is a big problem. So other building saved or big damaged in Onagawa. So we are now trying to get data on the damage in the building. So anyway, this is the some summarize of the tsunami damages. So we have very big inundation. This is 443 square kilometer, but it's exceeded to the 500. So it's very big effect with the very destructive wave force. So due to the secondary tsunami generation. And therefore, we have direct and indirect damages due to the tsunami. Especially the floating material, which is the sometimes ships or part of the building or cars or tanks are moved by the tsunami. So it's caused more high damages on the coast. And the fire happened, and still we have the salt water in the plain areas. So here you can see the big ships, and the fire happened after the attack of tsunami. And here you can see the damage of the new Fukushima nuclear plant. This is the first wave. So one staff member in Fukushima took these photos. So this is breakwater and overlap the tsunami coming and reach to the coastal area. And this is some facility. So here we have reactor or very important facilities. And it's inundated and going to the inside. And Onagawa here, less damaged. However, some water affect to the some area. So maybe the member of the Tohoku, EPICO, is going to present us more detail. And this is the result of the tsunami attack on the facility along the coast. This is the gauge in the rivers. So it's partially damaged, but there are some. And there's another bent steep piers in Onagawa, like this. And this is the seawall. So we have many data on the damage. This is the seawall. Due to the wave pressure, it's moved horizontally, not rotated. So we can see such a scenery. So here, again, showing some photo to take first attack of tsunami in Sendai. So the Kyodo Tsushin or Mainichi Shimbun take a helicopter, go up and to take this kind of photo, series of photo. So as the professor Shoji mentioned that in the beginning, the tsunami, which have very high potential energy. So it means the water go up and down, and it propagate from the source to our region in the coast. So you can see the uplifted sea water here. But this is very calm, not destructive. So even if we are on the boat, so we cannot identify we are now on the tsunami. So it is very calm. But tsunami reached to the coastal area, so potential energy changed to the kinetic energy. So just slow to the lower area. Then the velocity of tsunami can be accelerated, so kinetic energy becomes significant. So it's caused of the huge damages. So a few minutes later, the condition of the sea offshore, it's almost same. Because the tsunami is long wave, and for a long time it's go like this, and gradually go down and down, go up and down. But you know, the front of tsunami, very violent. The velocity are now accelerated and become large. This is another photo. So you can see the front of the tsunami like this. So in the beginning, tsunami reached to the almost same time and the same area. But after passing some land area, we found some differences in front. So for example, we know we can see the very first tsunami arrival here and there. Might be tsunami passing across this area. It is a little bit lower area, and this is also lower area, and many forests, controlled forests, are destroyed by the tsunami. Yeah. However, in this area, in the middle, forests remained, and later we measure the ground level. So only 1 meter or 2 meters higher than the others. Yeah. So tsunami might be affected by the very local topography, even on the plain. So we can say that this is very safe for the tsunami, but this is very risk for the tsunami. So we need very detailed analysis for the tsunami risk by looking at this one. So, and here the forest remained, and this is another forest remained. So we check what condition to control the damage of the forest. Of course, the type of forest or trees, or age of the trees, or height of trees. So one of major factor to control the damage on the tree is not age, not kind, which is the roots, height of roots. So when the forests are planted on the very lower area, the underground water like this, and this is the ground level. So roots of the pine tree or another tree is very short. However, the tree on the higher level, so roots going down to attach to the groundwater level. So now here more than 2 meters of the roots. So then the strength of the tree against the tsunami is very large. So we found such kind of information. So anyway, the tsunami. Sorry. Again, I should mention another thing. So this is remained. So tsunami reached to the canal. So canal is the one of vulnerable area for the tsunami, because the small tsunami once coming to the river mouth through the canal, tsunami can reach to this area. So it is one of dangerous area. However, when the large tsunami coming, tsunami reach to the canal, so you can see the very big violence. It means turbulence. So it might dissipate a tsunami in the front, and the tsunami go down to the canal and try to go up to the another area. So it's cause of the delay of the tsunami arrival and also energy loss. But this time tsunami proceeds to the inside. This is the forest control area and this canal, but cannot stop the tsunami. And this is Sendai International Airport. The tsunami here on the area can accelerate it again because this is flat. And here you can see the many cars. More than 500 cars are parking there, and all cars are damaged, including some helicopter or some aircraft. So you can see now the change of color of the water. Now, originally tsunami, the color of water should be blue. Okay, it's very natural. However, you can see here from the blue to brown or black. So it means tsunami make big erosion. Some sand or mud on the bottom, tsunami should be make some transport such kind of some mud or sand. So this is the demonstration of the tsunami propagation to explain such phenomena. So when tsunami coming to the shallow region, it's amplified, and from surface to the top, tsunami velocity very unique, so very strong. Then the tsunami become very large, and it cause the big erosion. And we have the many suspended load. So like this. So it is the cause of another kind of disasters. So the water density now become large. So normally salt water offshore just 1.02 or so. However, now this is 1.2 or 3. 20 or 30% of density can be large due to the contamination of the sediment. So now we are trying to develop the sediment transport model in the case of tsunami. Tsunami itself, just water. But when some bottom stress can be large, and it's caused some suspended load or bed load. So it's changed the topography or change the density. So this is a very primary model we apply to this case. So this is the several numerical result with 4 layers. So this is the tsunami go up and down water level showing the tsunami propagation. And this is the bedrock flux. So when tsunami coming and the shear stress on the bottom become large, so we have kind of erosion. And it's moved to the inside or offshore, so it moved. So this is a suspended load. So big attack of the tsunami, some soil or some small material pick up inside to the water. And here, last layer, it is change of bottom. Some area eroded and some area deposit. So become some more, say, the lower or other area larger. So please look at some result. So tsunami coming is around 1 hour after the earthquake. So tsunami here and here. It's big first wave, and it's bed load, and this is suspended load inside and shoreline. So blue one is erosion, and red one is the deposition. So big part of the sand dune eroded, and it's transferred to the inside. So where we have the tsunami deposit sand layer, so which is same as the 869 Jogan earthquake tsunami. But this time the thickness of the sand layer is very small compared with the 800 years. So anyway, we are now time to build the new society, especially the resilient society for any kind of natural disasters. So this is a plan to make regional areas. So we need to protect the tsunami, or we prepared more efficient system in the city for evacuation from tsunami or flood, or more resilient tsunami. So this is the example of the Sendai cities. So you already seen the attack of tsunami. So this time, the controlled forest or open canal is not enough to stop, but it's very important rule to mitigate or reduce some part of the tsunami energy, we believe. So before the 2011, we keep this kind of green belt, and this is rice field, and some community are located. So now we are discussing about multi-layer tsunami residential cities. So in the past, we tried to construct the only sea wall. So it's become very high, 10 meter or 15 meter. But it is not good for environment, and it's very cost. So we try to reduce the height of the sea water along the coast. However, tsunami might become, then we need a kind of natural forces by the controlled forest or elevated land area. And sometimes we need some evacuation place, which is the shelter, to save the life. And here, this is the highway. So in Sendai, we can get very good practice. It put a good example to save their lives. So we are now proposing this multi-layer structure for the tsunami in the future. So now we are at the new stage by starting the new research institute. I belong to this one, International Institute of Disaster Sciences in Tohoku University. So I belong to the natural disaster risk research or some sciences and technology. But this time, the social scientist, historian or some psychological and regional expert join us, and also disaster medical team also joined. So we are now very interdisciplinary group to understand what happened in this time, and we should improve our experiences. So this is the logo. We have the nickname of Irides. So Irides is the plural of the Irides. So it means symbol of the desire or nobility. So it's you can see, or we hope you can see some Irides here. But here, sorry. This is the this is another meaning of the logo. So actually, we have the disaster, natural disaster. So Chinese character of natural disaster, disaster is like this, two Chinese character component. Y is the damage. So this is Chinese character. So when we have the disaster, but we try to overcome this kind of damage. So this character change from top to bottom like this. So here you can imagine this is the top part of the here and this part on the bottom. So the meaning of the logo is to overcome our situation. So thank you very much for your attention. So this is my talk in the morning. Thank you very much.